Hello and welcome back to Phoenix LiDAR Systems demonstration of SpatialExplorer 6. Here we will be demonstrating the export function of SpatialExplorer to export our point cloud into a finalized LAS or LAZ file. So we've gone through post-acquisition, we've processed our trajectory, we've calibrated our point cloud, calibrated our camera, extracted RGB to our point cloud, as well as done classification efforts and reporting and other analytic work. Now we're ready to export our point cloud into a finalized LAS or LAZ for use in other software or for delivery to a client. So now that we have our point cloud here, ready to go in our calibrated glory, we can find our way to the Edit tab here. Let's find our way to the Export Cloud button. Here we're able to create an output file. Let's say here in our demo data, let's say demo output. We're going to be outputting an LAS file today, and we're going to make sure we are using the same intervals we used before. If you wanted to create a selection within your point cloud in SpatialExplorer, you can export solely that selection, but today we're going to be exporting this whole project. And our output coordinate system, we've seen this dialog once before, but it's a very important one. For the user-defined compounds CRS, today we're going to be going for UTM-11 North. We're going to be using this in the NAD83 datum. There we go, NAD83 2011 datum. If we go back to that window, we can make sure our vertical coordinate system matches what we want, NAD83 2011. And most importantly, our unit here. You can use meter and meter for a vertical. With that said, we can certainly use any of these EPSG codes or coordinate reference systems in a different unit without an issue. Also, once again, we're able to import well-known text or maybe a Proj4 code for specific coordinate reference systems in that format. Here also I have my favorite CRS here. I'm just going to select that to make sure I'm consistent with my other product and make sure we are at LAS. Our other options here, we could write only the colorized points, only the points that were RGB extracted, ignoring any other points outside of the photo footprint, or perhaps single return points, or even creating one individual file per interval, per flight line. Since this is a HDL32, we're going to be creating an index of the laser head in the user data field, making each laser an independent attribute. We'll utilize the time format of time of week, even though we have many other standardized systems. And our point source ID for today, we're going to be using the index of interval. So we have a point source ID that specifies the flight line number. We're going to be exporting all of our classes, although if you wanted to solely export your ground class, you could. Maybe the couple trees we isolated in classification as high veg. But today we'll do all. And many other little options. We can write our trajectory as an LAS file so we can visualize the trajectory in tandem with our point cloud and other softwares if desired. And we can also create the same report we saw from previous modules within the same dialog. So let's go ahead and hit OK and let that run. Excellent. Now that we've exported our point cloud, we're ready to use this point cloud and the deliverables created from it in any other software, or we're ready to zip up and send to the client. I hope you've enjoyed these modules, and I look forward to seeing you here in our SE6 demonstrations again. Thank you.